Okay, so let's continue with problem solving for topic 5, which is probability. Remember that these problems are extracted from our textbook, adopted textbook by Keller. Okay, so what do we have here? This is problem 6.47. We are given the following probabilities for these events. Okay, probability of A is 90%, probability of B given A, 40%. So let me get my highlighter first. Okay, here we go. So this is the condition probability. This is the simple event, probability A. And what that? This is the probability of the complement of event A, 0.1. Yes, obviously, when P of A is 0.9, that means its complement is 0.1. And we're given that probability of B, given that the complement of A happened, is 0.7. And we need to find all joint probabilities. So what do we have here? We have A and AC, and we have B, and of course BC. The best way to find all these probabilities is to build the probability tree. We can always use the other method, which is using the condition probabilities, because you know that the condition probabilities equation has the joint probabilities. So we are given joint conditional probabilities. We can find the joint probabilities, but let's make it simple. And in fact, it's a good opportunity to learn more the probability trees. So here we go. Let's build it. Okay, remember how did we build a probability tree? We start with the first node, all right? So in the first part, we have it's either A or AC, and we are given these probabilities, so we simply write them down on the branches. 0.9, 0.1, which comes from this and comes from that. Then the second trial, okay, it's about observing the second event B. So given A, we can either observe a B, so here we go, you see B given A, and B given A, we are given the probability that this is 0.4, which comes from this. Here we go. All right. And so it's either a B or its complement. Here we go. That's why on the second branch we have BC, but also given A, right? Because these two branches come from this unique branch where A is observed. Now, BC given A was not given to us here, right, in the given data. However, we could conclude that because coming from this branch, we have two branches, and the probability of one branch is 0.4, so this will give, obviously, the second branch a probability of its complement, which is 60%. So here we go. So this will take care of the first branch. Second branch is when AC happens, so the complement of A. Okay, and we know that this comes from here. Here we go, we are given that. Now, when the complement of A happens, again, it's either a B that will be observed or its complement, and that's why we are referring to these condition probabilities. Now, B of AC 0.7, here we go, we're given here. And we are not given BC given AC, but we can conclude that, right? We can conclude it because this is the second branch, and there's no third one, so that's it. It's 1 minus 0.7, which gives us 0.3. And that's it. Now we are ready. Let me try to erase these because it's becoming hectic now, or I don't want to lose you guys. Here we go. Okay, and now we are ready to find the joint probabilities. Remember, first, what do? We name the events. which comes from these branches. So this comes what? It's an A and a B. Here we go, A, B. Then A and B, C. Here we go. Then AC and B, AC and B. And then AC, BC, and AC, BC. And for the probabilities, this is the simplest part of it, where we simply multiply the probabilities given on the branches that lead to the final event, right? So that's why this is 0.9 times 0.4, 0.9 times 0.4. Second one, 0.9 times 0.6. So here we go. Third one, it's 0.1 times 0.7. Here we go. And finally, it's 0.1 times 0.3, and we got these. You see, and remember, as we discussed in class, that the sum here should equal to 1. All right? All right, so here what do we have? This is problem 654. We have 100 students in a class. We know that 10 are left-handed. We all know that this is the left-handed are much less. The number of left-handed people are much less than the right-handed, and this is illustrated in also a probability, right? So we are given that the probability of left-handed is 10 out of 100. Okay, so that's 0.1. And we are given that 2 students are selected at random. Okay, we want to draw the probability tree and get the probabilities in each branch. So what do we have here? We are drawing two students, so we're selecting 2 students. So we always do that, even if these two are selected simultaneously. Let's say we have the name of all the students in one box, and we can pick up two papers, okay, or 2 names. Even if we do that, that does not mean that we cannot follow the following logic in a probability tree. So we say that the first trial, we either get a right-handed or a left-handed, and then we have the second picking or second choice. Again, it's either a right-handed or a left-handed, but these are what? These comes from the first one being picked and found to be right-handed. That's why we show that in the as a conditional probability. And the second one, if the first one was left-handed, then again I have the likelihood of observing a right-handed or a left-handed for my second selection. Again, these are illustrated in these conditional probabilities. Now let's find the probability for the first picking or the first choice or first selection. Okay, this one first, and this is our second. Here we go. In the first one, what's the probability that the picked person is right-handed? We know from the given that 10 out of 100 can be left-handed, which leaves 90 out of 100 can be right-handed. So here we go. We have 90 here, and we have 10 out of 100. Now, if the first guy selected was right-handed, which means what? Which means we still have 89, right-handed, and we are now picking out of 99, a population of 99, not 100 anymore, because here we go, we have already our first selection done. So you see that all here in the denominator we have the 99. Why? Because we already have done the first selection. So this is very obvious for us. Now look at the numerator, which is also not very hard. Given that the first one was right-handed, so if the first one was right-handed, which means that all the 10 which are left-handed are still in the population, and which make the probability of picking now a left-handed is still 10 out of course, 99. Now here, if the first one we selected was found to be left-handed, so the probability of finding the second one to be right-handed, we still have 90 possibilities, right? 90 students who are all right-handed, they are still in the population from which we are picking. And we are picking out of 99 as we discussed before. Now, if that was left-handed, which leaves only 9 people from whom we are selecting, right? So that what will make then this branch has a probability of 9 out of 99. I think these logic, okay, or reasoning, I'm sure that you are becoming more and more familiar with. So I strongly advise you guys to do your own also practice, and I'm sure you will nail it. Again, here we come to the stage where we are simply listing the event. So it's right, and we write it here. Then right and left, so right, left, and then left, right, and left, left. And multiplying probabilities, I'm sure that now you agree with me that this is the simplest part of it, where we simply multiply the probabilities that we identified on the branches. So that's the first one multiplied by the second one, and here we go, we get all these probabilities. Okay. All right, now that we have the probability tree done and the probabilities determined or calculated, now as we discussed in class, this is where the fun starts. It's simply a matter of reading from the final branch on the probability tree to answer any question, okay, about the probabilities. So the first one, probability that both are right-handed. Okay, so remember, we'll be reading here always, or we will be identifying the outcome here. So here we go. Both are right-handed. Both are right-handed. So that's it. I have only one event here. So all what I do, I read its probability. Here we go. All right. Second, both are left-handed. Also here, I look, what are the events that satisfy my condition? Here we go, I have only one, left-handed, or both are left-handed. So I read its probability. Here we go. Now, one is right-handed and the other is left-handed. I have two events that satisfy this condition, which are those in the middle. So here we go. What we have to do is to sum their probabilities. Okay, so we're talking about these two. And finally, at least one is right-handed. What does it mean, at least one? That means it can be either one or two, which means that now we have three events that satisfy this condition. It's either that the first one was right-handed, okay, and the second was left-handed. I have at least one, which is right. And also the second event, which was made by the first one selected was left-handed and the second right-handed. So I have at least one right-handed. And also we have an event where both are right-handed, which satisfy that at least one is right-handed. So this is a union rule. We sum up their probabilities and we find this to be 0.99, which is very high because the probability of right-handed is 90% at the first place. Okay, so I hope that these problem solving help you reinforce more your knowledge about probability, and I strongly advise you to do your own practice, and I'll be there for you if you need to ask me any question. Thank you.